Hello, welcome to the video. So, you probably clicked on this because you wanted to learn about wormholes. Wormholes. So, wormholes is, as you've probably guessed, a pretty complicated subject. And there are many prerequisites in order to understand wormholes. So I think I'm just going to run through them really quickly. The first one is a basic grasp of dimensionality and the difference between dimensions, right? So I think everybody's heard before, the movie was in 3D or 2D, but what does it actually mean for something to be three-dimensional, two-dimensional, one-dimensional, and even fourth-dimensional? So you have the first dimension, the second dimension, the third dimension, and the fourth dimension. We live in the third dimension. And what does that mean? It means that we have three directions. We have forward and backward, left and right, and up and down. And you can say, well, what about diagonally? Well, diagonally is just a combination of forward and right. And it really doesn't matter which way you turn, but with any of these two, you could achieve any direction this way. And with the third one, you can achieve any possible way that you could point, right? So the third dimension would be, this would be the third dimension. This cube here, right? Because this cube has a left, a right, an up and down, and a back and a forward. Two dimensions would only be like this. No concept of up or down, just simply left, right, backwards and forwards, and any combination of those. Obviously it doesn't have to be a square, it can extend infinitely, but just no matter how far somebody walks on a two-dimensional plane, they'll never go up if they walk for their entire life. And one dimension is just a line. And fourth dimension, since we don't live in it, we can't imagine it. So I'll just put a question mark there. In order to understand the difference, the real difference between all these dimensions, I think it would help to go through this thought experiment. Imagine you had a microphone that allowed you to speak into the second dimension. And here's the second dimension. So imagine that this square is the world of this little guy over here. Let's draw this little flat circle guy. Maybe give him a mouth, maybe some eyes. Okay. So you have this little guy over here, and well, actually his eyes wouldn't be on the top of his head. They would be over here. Let's say these are his eyes, right? And this guy can see in this direction and this direction, but there's no way that he can see up. And you have a microphone that allows you to talk to him. How could you explain to him the third dimension, the concept of up? What are you going to say? Well, it's outside of what you know, but that really doesn't mean anything to him, because to him, outside of what he knows is like, let's say this is his house, outside would be stepping out of the door, still on the second dimension. He has no way of thinking about up. But what you could do, let me finish this house just for continuity's sake. But what you could do is you could go to this two-dimensional guy, and you get him to look at the line at the first dimension. And you can say, well, to this line, the line would have no way of understanding left and right. The line only knows forward and backward. So you can see that there's something extra that you have that a line doesn't. And we have one more of that extra thing that you don't have. We have the third dimension, up and down. And with this in mind, imagine a fourth dimensional guy was coming and explaining it to us. He'd probably use a very similar method and say, hey, there's no way that you can imagine this, but we have a fourth direction. And try to picture it. You can't. Try to picture, you have a cube, and then where's the fourth way to go? Diagonally? No, that's just the combination of forward and backward, or left and right. So it is another way, another dimension that we have no way of understanding. Okay, so that's dimensionality out of the way. Okay, so now that dimensionality is out of the way, let's move on to the next bit that we do in order to reach the goal of wormholes. So to this square, on his square universe, or this circle, on his flat universe, everything to him is flat, and he has no concept of up or down. But now let me draw something, and I think you'll get it once I draw it, so let me just jump in and do it. What if his universe looked something like this? What if it looks something like this? Now you would say, well, that would make it three-dimensional, not two-dimensional, because in order to make this shape, right, a curved flat shape, like if you folded a piece of paper, it would have to be three-dimensional. But if you think about it, let's say this guy is sitting here. These are his two eyes. Let's say this guy is sitting here. To him, and this is kind of hard to wrap your mind around, but to him, this is as if it was flat. So this would be the same as this, and he could have his house over here, right? And he knows how to go out of his house, and he knows what to do. But he has no idea that his universe is curved, because he can only understand the second dimension. He only knows left, right, forward, and backward, and he has no concept of that his whole universe is curved. So this is interesting, right? It's an interesting little thing. But you could really do this in any shape, right? Like imagine his universe is wavy, right? Right, and here's the guy with his eyes. For him, this distance from his house to the end of his universe is, let's say, 10 feet. And to him, he sees no difference in this scenario as this scenario, because he has no concept of the waviness. So even if, technically, if we were standing over here, we wouldn't be able to see over this hill, but to him, his line of sight goes like this. So he is able to see through the waviness, because it's in the third dimension, he doesn't exist there. So here he'd be able to see to the end, just like here and here. It doesn't matter the shape of his universe. Okay, so now this is all fine and good, but it doesn't really affect the two-dimensional being. It's just a cool thing for us to say. We can look at it and just to confuse the poor guy. But there is some shapes that do have some practical ramifications on the second dimensional being's life. One of them being if the guy lives on something that's rotated, something that you can circle around. And so here he is in his house, and he can see all the way to the end of his universe, and he sees on this side and then behind the wall. I mean behind on his side, right? But if he looks far enough, he'll be able to see the back of his house, which doesn't make sense at all, right? Here, 10 feet, he sees the end of his universe. Here, 10 feet, he sees the end of his universe. And here, 10 feet from him, he sees the back of his house, the back wall of his house. And that's fascinating. There would be no way he would even understand that. It would just be like to him, he walked outside of his house, walked some steps, boop, 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 walked around, and all of a sudden was back at his house. It's like you leaving your house, taking a trip, and then all of a sudden ending right back at your house. And we can understand that because we know the world is round. So you can say, well, you went around the world, but you wouldn't even know that you were going around the world. You would literally not be moving at all. You would be, according to all of our measurements and all of our calculations, traveling in a straight line and still somehow ending up back where you came from. Like now we can tell that we're changing direction slightly when we go around the earth, but even if you were going perfectly straight, to you it would appear like you're going perfectly straight, but you'd actually be able to appear right back at your house. And this is one of those, but not really anything where it connects with itself. Like if you had a sphere, right, you could have this guy over here on the sphere, and his house is over here, right, and you can see all the way around, go any direction, and end up back where he came from. And if you take this idea and just try to imagine what that could mean for the third dimension, for us, right, that would be, we don't know what the shape would look like, obviously, because we can't hold the fourth dimension in our head, but it would have the same idea where you would be walking, and then all of a sudden, if we travel millions and millions of light years, I assume, I don't know the shape of the universe or how big it is, but theoretically, if it was this shape and not any of these, you would be able to reach the same space. And it also means that our universe is finite. It is, to this guy, it's infinite because he can keep walking and walking and walking, but to us, it is finite. You can hold it in your hand, you can see it, it's a sphere. Maybe it's a really big sphere, but it's not infinite. Now let's get to wormholes. You're still probably wondering, how does this have anything to do with wormholes? And I'm going to draw another shape, the shape of a wormhole. And this is the theoretical shape that if our universe has this shape in it, it will have some crazy ramifications. That shape is this. Here. You've probably seen this image before. If you, I don't know, maybe you haven't. But imagine this shape occurred in the two-dimensional person's universe. And imagine his house is over here, and he's living over here. And he's got his little house. And he wants to get to his buddy who lives over here on the underside of this. And to him, to us, we can see that it's curved, but to him, it just looks like it's straight. And if he looks far enough, he can see that it's straight. Is if he is standing on this corner, this back corner, and decides to walk, it would take him, let's say, 10 miles to get to his friend's house. But all he has to do is move a little bit to the right, and instead of walking this way, he walks down through the wormhole and pops out on the other side over here. It could only be potentially 10 miles of distance. And he would have no idea why the distance was different. But we know, we can see very clearly that he just walked inside of here. And something crazy is, if he's standing here and looking with his telescope, his line of vision would go all the way around, and he'd be able to see his friend. But if he stood a little bit to this side and looked with his telescope, his line of vision would be to his friend, and his friend would look bigger because his friend was closer. So it would be very, very weird, shifting in side to side, and the size of his friend becomes different. And you could have some really crazy things where, imagine there's he's reached a point in the universe where it's very, very small, where the curvature is very small, right? Let's say he's standing, let me try to imagine. Let's say he's standing on like a little thing that's sticking out from his universe, right? Let's say his universe is here, and then there's some protruding bit in the third dimension. Assuming that he was standing here, right, and he was looking this way, it would be very, very short distance to see his literal own back. So there could be points in his universe where he's walking normally, and then all of a sudden he enters this protrusion, and then all of a sudden he's looking at the back of himself. And not only looking at the back of himself, he can reach out and touch himself, which is just spatially incomprehensible as if you have no idea of the third dimension. So this is all within the second dimension. So bringing it from the second dimension to the third dimension requires an understanding of the third dimension, right? Which is this. So bringing it from the third dimension to the fourth dimension does require some sort of knowledge of what a fourth dimensional shape would look like, which obviously we don't understand. But we can take these concepts and know that they would apply if our universe was shaped fourth dimensionally. So you could have, theoretically, somebody traveling in space, and then all of a sudden leaving their spacecraft and seeing themselves from the back and being able to touch themselves. And you would also be, I assume, be able to see yourself and seeing yourself, and it would just be like a line of views, like two mirrors, which is just fascinating. You'd be able to do massive lengths of travel, assuming you found this wormhole and they were possible to exist. I mean, if that's the shape, and be able to do travels of millions and millions of light years in potentially seconds, depending on how convenient the wormhole is. So, yeah, I guess it's just something that's interesting. It's the first video, and yeah.